Hello everyone, Mindful Maths here. Jan 2020, Statistics 1, walking, talking, mock. There are a few mistakes in the videos, but watch, see if you can spot them. They will be corrected during the video. Have good luck for your exams, and I hope you find this useful. Question number 1. The discrete random variable x has the following probability distribution. So first of all, what do we know about this probability distribution? We know when we add all of, what do we get? 1. Okay, so there's our first equation. 0.15 plus a plus b plus c plus 0.15 equals 1. So that means a plus b plus c equals 0.7. Okay, because I added the 0.15s to take them away from 1. Then, the next clue it gives us is that the mean value of x is 1. Okay, the mean value is 1. What does that mean? That means our expected is 1, okay? If our mean is 1, that means that this is symmetrical, okay? Because we can see here that our middle number is 1. So this means it's symmetrical. What does that mean? That means that A and fact equals C. So there's another clue that they've given us. A equals C. Okay? So in here, technically, you could say 2A plus B equals 0.7. Or 2C plus B equals 0.7. Okay? Because we know that A equals C. Then we keep reading. We've got the next clue. Our frequency of 1 is 0.63. So that means these three add up to 0.63 because it's our frequency of 1. Okay, and if you were to write here your f of x, if we're looking at our frequency of x, you know that this is 0.15. You know this is 0.15 plus a. This is 0.15 plus a plus b. What is this last one here? 1. Yeah? And then this would be your 0.15 plus a plus b plus c. So actually, we've got a bit more information now. We know that 0.15 plus a plus b equals 0.63. So that means a plus b equals 0.48. Now, simultaneous equations is essentially what we have here. You could do this in a multitude of ways, but if we know that 2a plus b is 0.7 and a plus b is 0.48, I don't have to actually physically do a simultaneous equation for you to know that the difference is a is 0.7 minus 0.48, which is 0.22. What did we know earlier? That c is also 0.22. And then therefore, B is 0.47 minus 0.44, which is 0.26. So there we go, 5 marks. We've worked out the values of A, B, and C. So remember, with these types of questions, they're going to give you clues, you know the rules, and then you can form the equations. Question 2. A group of 40 families were asked whether the family had a dog, a cat, or rabbits as pet. Now, if I've got a dog, cat, and rabbit, how many variables do I have? 3. So I know that my Venn diagram is going to have how many circles? 3. So I'm going to draw a box. I'm going to try my best to draw 3 circles, and then let's start labeling them. Dog, cat, rabbit. Obviously, if you label yours slightly differently, you're not going to have the same. Yours will just look a bit different. And what is the total? How much should it be altogether? 40. So we know that 40 should be the total. So what I'm going to do is I'm going to read through the clues. Now, with some reason, you can, I always start at the bottom work my way up. I read these clues a few times before I get going, but let's actually see what's going on. 9 families did not have any of these animals as pets. So straight away, 9 goes on the outside. That means that all that's left in those circles has to add up to 31. Okay, so now 11 families had a rabbit. Okay, so a rabbit, so I know is 11 needs to be the total. So I'm just going to write a little 11 there. It's basically like a Sudoku, isn't it? 14 had a cat, and 12 had a dog. Okay, so I need to add all these up. 12 plus 11 plus 14 is 37. How many is over? 6. So that's how we know that 6 goes in the middle. Okay, because what should they all add up to? 31. They all added up to 37, all right? Then we'll start. 2 families had both a dog and a cat. Okay, so you know there's 2 families here that had dog and a cat. No family had a dog and a rabbit. And it didn't tell us any more information. Okay, so now we can start figuring this out. So if there's 0, 6, and 2, that gives us 8. We should have 4 left over. Because, okay, and then we know that that's 12. Okay, this needs to be 14. And this is 11. But how much is the overlap still? If we've definitely got 12, do we have any overlap? 31 minus 12 is 19. 25. So we've already accounted for the 6. Okay. So 2 plus 6 is 8. 8 to what is 14? 6. Okay. And then we've got 6. And what do we want?
So now rabbits are 5.
Is this 5 here? Okay. Now, what doesn't make sense about this? Yeah, there's no intersection with rabbits and cats, and we've put a 6 there. So I should have really read the whole thing twice. No family had a dog and a rabbit. So that means this needs to be 0 as well, doesn't it? Is this going to be 6 here?
But then the total for dogs will change.
Yeah, the total for dogs needs to change. So what is dogs going to be? So that's 10. And then
Cats will stay the same. Cats and rabbits will be 6.
yeah, we need to figure out the overlap now of this one. Okay. Yeah, we could draw it differently or just write 0. So if this is 14 and this is 11, 31 take away 12. Let's do that. 31 minus 12 is 19. So what's the overlap between these 2 and 19? Is it 6 still?
So 6 would go in the middle.
6 would go here. Does that seem right?
And it would remain 5 and 6 on the outside.
2 families had both a cat and a dog. 12 families had a dog. 14. 11 families had a rabbit. 9 families do not have any of these in pets. Right, is this definitely right then? So what's 2 plus 6 is 8. 6 and 5.
Yeah.
Okay. No family had a dog or a rabbit. 0, 0. Yeah, so you could have drawn it like this as well. okay, where you would have your dog and your rabbit here. And what else would you have? Cat. Okay. So let's try it again on this and make sure it works. 2 families had a dog and a cat. 12 families had a dog. 14 had a cat. And 11 had a rabbit. 9 on the outside. Okay. So this is definitely 10. This is, we made a mistake here. Guys, if this is 2, 2 plus 6 plus 6 is 14. 6 plus 5, 11. It does all add up. But 6 is the crossover between 14 and 11. Take away the 12. No, we haven't crossed this over properly. Because technically, what do we have left is 12 and 11. Okay, so 12 plus 11 is 23. And we should have 14 minus 9 minus 12. Between 23 and 19 is 4. Okay, so 4 is the crossover. Okay, that's an easy mistake to make when you're not, when it looks like that 2, we haven't included it, have we? But that 2 still needs to be thought about. And then obviously we've got 6, so this becomes 8. And then 4 and 11 is 7. There we go. Okay, so we made a mistake there. We've now rectified the Venn diagram, and then I carried on and forgot to hit record. So mutually exclusive means that they don't have any interaction. We see as D and R. Find the probability that the family has exactly 2 of these kinds of animals as pets. Okay, so what is the probability that we have 2 of these kinds of animals as pets? Well, exactly 2 is 2 plus 4 out of 40, which is 3 out of 20. Then part D says, showing your working, determine whether or not D and C are independent. Now, if they are independent, the formula says the intersection equals the probability of each one multiplied by itself. So the probability of D is 12 out of 20. Okay. Now, why have we done it out of 20? So we've done it out of 20 because we're only looking at D. So it's out of 20 because we're only looking at D and C, okay? And D and C has a total of 20. We multiply that by the probability of C, which is 2 plus 8 plus 4 out of 20. That does not equal our intersection here, which is 2, okay? So therefore not independent. Now, Sarah's family is in the group and her family has a pet cat. So that's given her family has a pet cat. The only thing we're going to be looking at is the cat section. So find the probability that they also have a pet rabbit. So it's 4 over 40 divided by 14 over 40. Because rabbit is 4 over 40. But whenever it says given, our denominator is always what it's given by. So probability of a cat is 14 over 40. Okay? But the probability of a rabbit given a cat, which means we can only choose the rabbits given this, is 4 over 40. Then you get 2 over 7. And then the last one, find the exact value of D union R, given, not C. So this blue highlighted bit is not C, which is 26 out of 40. That's why we have this here. And the reason I've written it in this form instead of like this is because some of you are putting it into your calculator and getting the wrong answers. So it's really important that we get that right. I don't know why, but some of you were doing this button and then putting the fraction on top here and the fraction on top here, and I don't know what was going on with the calculator. It was giving the wrong answer. So please make sure you either use brackets when you're using the division or you use actual division sign. So only out of that 26, what is D union R? Well, D union R is only these two areas here, and that's how we get that answer. Wait, I just realised. There you go.
Yes, we get these equations right.
Yeah. Yeah, we get the equations. Okay, question 3. Soapern sells washing machine. When a customer buys a washing machine from the customer is also invited by guarantee policy. Manager believes there is a relationship. M being the machines and P being the policies. And it can be modelled by the straight line. She collects the data for 10 months. What does that tell me? N equals 10. Okay? So, if N equals 10, we can then go from there. So, let's have a look. So, then we're given a bit of information, and it's asked us to show that S of MP. Okay. So, we literally get given this. Oh, God, sorry, guys. Yawning. So, S of MP is the sum of MP minus the sum of M multiplied by the sum of P all over N. So it was really important that we figured out earlier that N is 10 months. Okay, so it says show that, so it's really simple. We're just going to write down what we know. 32,958 minus 1124 multiplied by 281 over 10. Okay, and I think it's going to give me this. Someone check it. But you got 0. Let me see your work. Yeah? Perfect. Yeah, it says show that. Okay, then it says find the value of the product moment correlation coefficient. What is that? Yeah, but what is it called on the equation sheet? R. And it's S of, now it has X and Y's. What do I know which one's my X? It's the same as the axes, yeah? Because this is M, basically your M is your X, okay? So this is S, M, Y over, that's P, isn't it? Over S, M, M times S, P, P. Okay, so again, I have all the values. So, 1373.6 over the square root of 382.9 times 6,046.4. And what do I get? Remember, it hasn't told us, but what should we always do? 3 significant figures. I get 0.9027, etc., which is 0.903. Then part C says state, given a reason, whether or not the data are consistent with the manager's belief. So the manager believes that the more machines sold, the more policies sold. He's saying there is a positive, essentially, correlation. So R is close to 1, right? So that means the more of M is going to give us more of P. So it is close. It is close as R is close to 1. Okay, so the manager noticed that the total number of washing machines sold was K times the total number of guarantee policies sold, and suggest a model of the form P equals 1 over Km, where K is an integer. Find the value of K. So I don't know if you remember this in GCSE. This is like when you're given what is, so P equals 1 over Km. So we just need some figures. We have the sum of P, right? So we do the sum of P equals 1 over Km because he says it's been multiplied by the sum of M. So what do I know then? 281 equals 1 over K lots of 1,124. So I could...
1 over 281.
No.
2K and 281 also.
Oh, yeah, sorry. So, yeah, I wasn't doing that in my head. I was doing 281 over 1124 equals 1 over K. I'm hoping K's a whole number. So when I put this into my calculator, it's 1 over 4. So if 1 over 4 is 1 over K, then that means that K is 4. But yeah, you could also do that K equals 1124 over 281, either way round. So actually, we haven't really done a lot of thinking here, have we? Yeah? Okay. Jiang works for Sopan and thought that this model oversimplified the situation and suggested that a linear regression of P on M may be more appropriate. Find the equation of the linear regression where A and B should be 3 significant figures. Okay, so with the linear regression. Okay, so we can do this regression line. The equation is in the formula sheet. So B, which is S of MP over S of MM, and then A is the mean of Y, which in our case is P, minus B lots of the mean of M. Okay, so using the information we've been given, we're going to have 1,373.6 over 6046.4. Remember, we were given this on the page before, yeah? Put this in and I get 0.22717. I'm going to keep it as a fraction, all right? And then my A, my mean of, I'm going to get 281 over 10 minus my B, multiplied by the mean of my M, which is 1124 over 10. Okay, because remember it was over 10 months, right? So my A is 2.5653, etc. Okay, so then let's round these. So B is 0.227, 3 significant figures. A is equals 2.57. So now you can write the equation of the line where Y equals 2.57 plus 0.227 M. So there's your equation of the least regressions line. Oops, we should have written P, in fact, sorry, not Y. Okay, and then use the model to estimate when 70 washing machines are sold. So what are we literally going to do? Yeah, I'm going to substitute 70 into here. Like, you cannot get an easier question, you know. Plus 0.227 lots of 70. Okay, so then what do we get? $18.46.
Yeah.
Brilliant. Then it says usually about 70 washing machines are sold in January. So Pearson decides to offer a bonus to staff during January based on the number of guarantee policies sold. If the number of guarantee policies sold is greater than the number estimated by the model, the bonus will be paid. State, given your reasons, whether you would recommend that the staff use the manager's model or Jiang's model. Okay, so let's work out for both. 70 washing machines, that means that they've got to sell 18.46 policies, right? Or the manager's model, what that was KO 1 a quarter. Okay, so what's a quarter? So yeah, so 1 over 4 lots of 70. What's that? 17.5. So would you rather sell 18.4 to get a bonus or 17.5? Yeah, you'd rather sell the lower to get the bonus, wouldn't you? Okay, so the manager's model. So manager's model, as it gives a lower estimate. Okay. How many marks was that whole question? 13 marks, and realistically, it was just long-winded. In terms of the mathematics, was any of that mathematics hard? No, easy. Okay, question 4. Histogram is drawn to represent this data. So the bar representing birth weight. Okay, so if you think about, like, on the histogram bar, you know that the bar is between 1.5 and 250, yeah? So our width is technically 1, right? And our frequency is 16. So what would be our frequency density?
Maybe 16 or 1. Maybe 16 times.
Is 1 and the height is 4. So technically 1 times 4 equals 16. Yeah? Because our frequency is 16. Then it wants us to calculate the height between 3.5 and 4. Okay? Which is 0.5. And they need to multiply 3.5 and 4 is 14, right? So if you think about it, 4 times 1 is 16. So we just times it by 4. So 0.5 times something is a quarter of 14. So this is 7. Okay, so the answer to part A is 7. Now, there might be other ways to do this ratio. I like to use common sense. However, there are different kind of methods you can use. Then it says, use linear interpolation to estimate the lower quartile of the birth of weights of the 98 babies. Okay, so first of all, 98 divided by 4 is going to give me 24.5. So I'm looking for the 24.5th person. Okay? So 24.5, well, if you think this is between 0 and 16, 16 plus 24? 40. So between 60 and 40, this is where I'm going to find the 24.5th person. Now remember, linear interpolation is taking this like exact, it's like a literal thing, okay? So what I like to do is I like to draw this box. So here we go. We have, we know that this is between 16 and 40 people, right? And we want to find the 24.5th person. Now, if you think this is a bar model, between 16 and 40, it's out of 24, right? But how far along is the 16 to 24.5? It's 8.5, okay? So I want 8.5 over 24, like that's my fraction that I want of my width. So if you think of your width, this is between 2.5 and 3, isn't it? Between 2.5 and 3 is 0.5. So I want to know what is on this side, what would that be? So I'm literally going to type into my calculator 8.5 over 24 times 0.5. Now this tells me that this gap is about 0.177, etc. But what do I need to add it onto? I need to add it onto the 2.5. So plus 2.5. Okay, so then I get a total of 2.677. It hasn't told us how much, but what do we like to do? 3 significant figures, so 2.68. Okay, so this isn't using a formula or anything. This is looking at the bar, again, common sense. I think there is a formula, but I don't know what it is. Okay, part C. The researcher estimated the median and the upper quartile. Use the median and upper quartiles to describe the skewness. Okay, so remember, with skewness, Q1 is 2.68. Q2 is 3.14. And Q3 is 3.55. Does anyone remember what the formulas, etc., are for this? So if we were to, the best way to kind of do this, if we were to draw this, right? Okay, if this is 2.68, 3.55, where is 3.14? Is that going to be, like, are we going to draw a line directly in the middle? No, where are we going to draw it? A bit more to the right, aren't we? Okay, what would be exactly in the middle? 3.55 minus 2.68. Oh, actually, no, let's add them and divide them by 2. Divided by 2 equals, so right in the middle would be 3.115. So we can see that it is going to be slightly to the right, isn't it? Because right in the middle is 3.115. So this means that the gap between quartile 2 to quartile 1 is bigger. So when quartile 2 minus quartile 1 is bigger than quartile 3 minus quartile 2, we have negative skew. Okay? Now, it is 2 marks. You are going to probably have to do a little bit of writing down the differences. Okay? And again, you know, if, like, when you draw it out, if your median is here and you're more this side, what's that going to be? Positive skew, isn't it? This is positive. This is negative. So you're probably going to have to write, what is the difference between the median 3.14 minus 2.68? We're going to get 0.46 is bigger than 0.41. Okay? So nice and simple, and then you've got some top tips to learn there. Right, it says find an estimate for the mean birth. Okay? Now, what have they given us? The midpoint. This is back to GCSE. 16 times 2, 24 times 2.75, 32 times 3.25, 14 times 3.75, 12 times 4.75. But do I even need to do that? No. Why? They gave it to us in the question, so don't be an idiot. Okay, and have a look. We already have the sum of fx. How do I find the mean? What do we divide by? 98, absolutely. So we're going to have 311.5 divided by 98. So the mean is 3.178. What do we love doing? Three significant figures. There we go. There's the mean weight. Now, remember, I know I'm writing this messy and all over this page. Do I expect you to write full method in the exam? Absolutely. So let's get that clear. Then it says the standard deviation. Anybody know what standard deviation is? Yeah, so the mean. So standard deviation is the square root of the mean of the squares minus the square of the mean. Now, I know I've used x, but in our case, this is going to be our f of x, isn't it? Because we've used it from the table, okay? But I've just used x's in to remember the formula. Actually, if I put y, this might be better. Okay, so then this is literally going to be, all you have to do is figure out, so we're going to have 1051.125 all over 98 minus, now what did we just work out? 3.18 squared, okay? This is going to give me 0.78895, and what am I going to round to? What am I rounding to? Three significant figures, absolutely. Okay, nice and easy. Then part E says, use the formula skewness equals free mean minus median over standard deviation to estimate the value. Okay, so again, common sense, three lots of the mean, 3.18, minus the median, we were given that earlier, what was that, 3.14, over standard deviation, 0.789. It's literally that easy. I get 0.152 ... Now, for some reason, it has told us it wants the answer to two significant figures. What do I get? 0.15. Easy. Okay. The researcher read that birth weight should be approximately normally distributed and decides to split the class 3 to 3.5, and the frequency for 3 to 3.5 is 9, and the frequency for 3.25, sorry, 3 to blah, 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 is 23. State, given a reason, what effect this would be on the estimate for the mean. So basically saying that between 3 and 3.5, they've split this into two now, haven't they? And what did they say? 9 and 23. So imagine now this is split into two and this is 9 and 23, right? What effect would this have on the median? Well, what is the median, first of all? The median is 98 divided by 2, which is the 49th person, isn't it? Right? So, this is 40 to 49, right? So, if we have 0 to 16, 16 to 40, 40 to 49, 49 to, what's 23? 72. So the median group, the median before was 3.14, wasn't it? Yeah? Our median was 3.14, but actually, we now know that our median, if it's bang on here, our median is actually going to be 3.25. So the median is going to increase. Median increases to 3.25 as 49th value. Okay, so our value of 49th will be will be placed in the upper interval of the split. Does that make any sense? So basically, when it's split, it's like the end of the first interval or the beginning of the upper interval. It's not actually going to give us 3.14. Okay? And then it says, without carrying out any further calculations, state, given a reason, what the effect this change would be on the estimate for the mean. Now, do you think the mean's going to increase or decrease? Increase, absolutely. And the reason for that is going to increase because there are actually going to be more values if you think about it. There's 9 values that are going to be multiplied 3.125 because that would be the midpoint of between 3 and 3.25, and then between 3.25 and 3.5 the midpoint is 3.375, and that multiplied by 23. So actually our mean, we're going to have our sum of f of x is going to be greater than it is now, and obviously we're still dividing it by 98, so we're going to have a bigger so increase of the sum of f of x, etc., etc. Just find a way to say it nicely. Okay, the random variable x has a normal distribution with mean 10 and standard deviation 6. What am I expecting you to write? That the random variable, but what am I expecting? When you see this, you should say x is normally distributed with what? A mean 10 and a standard deviation. Do I put 6 here or do I put root 6? 6 squared, thank you. Okay, please write this down. All right, it's good practice. Now it says find the probability of x being less than 7. So I need to change this to the probability of z being less than. Now what is the formula? It's x minus the mean over standard deviation. Okay, now I've seen exam questions before where they put 25 here and people put 25 here when what should it be actually? 5 squared. Do you see? So it should be 5 here. So please watch out for that. So what happens when I do this? 7 minus 10 divided by 6 is the probability of z being less than minus 0.5. Okay. What does that mean? But how does this look, probability of z? What? So if I was to draw this, okay, with our z values, what are we given? We are given between 0.5 and 1. So we're given all of this, aren't we? This is what we're given. Okay, what are we not given? Yeah, we're not given this part here. So when I am using my z tables, when it says the probability of z being less than 0.5, well, where in theory would 0.5 be? Negative 0.5. Yeah, it would be on the left, roughly. I'm going to say here. Okay, so using symmetry, I know that if I find the positive value, okay, so I look on my table and I look at z equals 0.5, and then to find this little bit, because this is going to give me, because of symmetry, I want this bit, but remember when I look up this positive 0.5 here, it's going to give me all of this bit, isn't it? So I'm going to do my 1 minus. So when I look at the table, I look at the left hand side column. okay, of my z. I scroll all the way down, I see 0.50, and it tells me that I get 0.6915, okay? So once I get there, what do? 1 minus 0.6915, and my answer is 0.3085. What do we normally like it? 3 significant figures, so 0.309. Now, there is a way to do this on your calculator. Okay? So, what do? Now, if you've got the Casio Class Whiz, okay, you're going to click Casio. You're then going to go to 7. Okay, and what distribution do we have? Normal? Yeah? So, on your calculator. And you can also do this on a calculator, the f of x one, Class Whiz or something. Make sure that on the calculator you use the normal, and I think it's the CD distribution. And then for, in this case, to find the probability of x is greater than 7, 7 would be our lower bound. And our upper bound, put in a really big number, 10 to the power of 10, for example. And then it will generate this value, the 0.6915. Okay, so part B says, find such values of k such that this equals 0.6. Okay, so because we already know that 10 is the mean, okay, from earlier, if you think about, if we were to draw this, okay, so we know that 10 is the mean. Okay, this is our 10 plus k, and this is our 10 minus k. So now we know the probability is 0.6, right? So like technically our area here is 0.6. So then what do we know? If that's 0.6, I know that the green bit should add to 0.4. So I know that this technically 0.2, 0.2, 0.3, 0.3. So if I want to find a value of k, what I'm going to be looking at is I'm going to be looking for this value here, where I know when I do my 1 minus the area of the 0.2, I get the 0.8. Now, with the formula sheets, so what do I know? Oops. Or if you already knew what your 0.8 is, remember on the right hand side, guys, you know what that 0.2 is. So we don't actually have to worry. So we know the probability is 0.2, so we can get our z value from there. Perfect. Okay, so to find the probability of getting 0.2, what do we know? We know that we're going to have 10 plus k minus 10 all over 6 equals, now remember, this is going to give us our z value. If I look up 0.2, okay, a probability of 0.2 is going to give me a z value of 0.8416. This becomes 0.8416. Now, the 10s are going to cancel. So I just need to multiply both sides by 6. Oh my God, I don't have a calculator. Wait there. 0.8416 times 6. And then 5.0496 is my value of k. Hasn't said anything, so I'll probably do it to leave it like this. If you wanted to, you could round to 3 significant figures, which is 5.05. Okay, and then part C, we can do over here. So a single observation of x is to be taken. A rectangle is drawn on a centimetre grid with vertices having coordinates. Okay, always draw this up. 0, 0. Okay, x 0. Okay, so we know it's along the same. X minus 3. Okay, so that's got to be here. I'm going to move this now to the side. X 0, 0, 0. I'm assuming the other one's down here because it is a rectangle. And then it's 0. Perfect. And x minus 3. Okay, so here is our lovely rectangle. Now, what do I know about this rectangle? I know straight away that my width is x and my length is x minus 3. Find the probability that the area of the rectangle is more than 40. So how do I do area? X multiplied by x minus 3 is greater than 40. So I'm going to have x squared minus 3x is greater than 40. So x squared minus 3x minus 40 is greater than 0. Okay, we can factorize that, yeah. 8, negative 8 and positive 5 greater than 0. Now, what does this mean? Okay, this means x equals 8 and x equals negative 5. Oh my God, I have to use some pure 1 knowledge here. If we think about this graph, crosses at minus 5 and 8. If we want greater, okay, it says greater than 0. Where is the graph greater than 0? Here and here. So that means I want x is greater than 8, but x is less than minus 5. I haven't seen a question like this before. This is exciting. So now that I've figured out the probabilities I want, so I want the probability of x being greater than 8 and or it's supposed to be not and, or the probability of x being less than negative 5. Remember, this is the same as saying 1 minus the probability of the interval of them. Okay? Because essentially we're taking away the probability of this bit. Perfect. We know the probabilities add to 1. So either way you write it is fine. So what do we know? We want the probability of our z being greater than, so remember it's always 8 minus 10 over 6. And we've also got the probability of z being less than minus 5 minus 10 over 6. Okay, so let's do one at a time. This is the probability of z being greater than 8 minus 10 over 6 is negative a third. Okay, what is the probability of z being greater than negative a third? What am I going to do here? And plus the probability of z being less than negative 2.5. So how am I going to find these answers? They don't give this to us in the table of the negative 2.5 and then minus a third. Is that the same as? Okay, so remember I can either use my calculator using the new trick I found, or we know this is technically negative 0.3333. When I look on my table of positive 0.33, so I'm looking down that Z column at the positive 0.333, it gives me my probability of 0.6293. Perfect, so we need to add that to, now minus 2.5. This is the same as finding the probability of 1 minus z is greater than positive 2.5. What is the positive 2.5? If I have a look down, 2.5 is 0.9934. So 1 minus 0.9934, I get 0.0062. Add them together, 0.6355. 8 marks. Absolutely lovely. And here's all the working out. Okay, so question 6. Tennis tournament has 5 rounds. After each round, winners go into the next round and the losers are knocked out of the tournament. To enter the tournament, players must pay an entry fee of $10, but only the person who wins all 5 rounds receives the price of $260. Serena enters this tennis tournament. The random variable S represents the total number of rounds Serena wins. The probability distribution of S is given below. Show that K equals 20 over 49. So, what do we know? We know that all of these is going to add up to 1. So, because it says show that, you need to be writing K plus K over 2 plus K over 3 plus K over 4 plus K over 5 plus K over 6 equals 1. I know there's an easy way to do it. What are we going to do? We're going to factor out K, obviously. Okay, and then we're going to have 1 plus a half plus a third plus a quarter plus a fifth plus a sixth equals 1. If I put that into my calculator, divide it, what am I going to get? 147 over 60 equals 1. So then K equals 20 over 49. Now you do have to write either one of these and this one to get the mark, okay? So, part B, find E of S, nice and easy. 0 times K, 1 times K over 2, 2 times K over 3. Now, it's a 3-mark question. Am I expecting you to write this out? Yes. Don't shake your head at me. This is a yes. So what I'm expecting to see is 0 times K. 20 over 49 plus 1 times 20 over 49 over 2 plus 2 times 20 over 49 over 3 plus 3 times 20 over 49 over 4 plus 4 times 20 over 49 over, how far do we go up to? Oh my god. 5 plus 5 times 20 over 49 all over 6. I am expecting you to write this. It's a 3-mark question. Okay? Now when you put this into your calculator, you should get 71 over 49. Now, I think the easiest way to do this is when you put this into your calculator, write 20 over 49, and then you can put answer in each time. So you can do 1 times answer over 2 plus 2 times answer over 3, etc., etc. Okay, next one. Find Serena's expected profit if she enters the tournament. Okay, so entry fee of $10, but the only person who wins all 5 rounds receives the price. So what's the probability of her winning all 5 rounds? It's answer divided by 6. So it's 10 over 147. Okay. So 10 over 147 is the probability that she wins all 5, because that's k over 6. Right? And her expected profit, we need to multiply this by 260, because that's the prize we get. And then remember, it cost her £10, so minus 10. So times 260 minus 10, her expected profit is 7.687. But when we're dealing with money, 2 decimal places, 7.69. Okay, next part. Roger also enters this tennis tournament. Given that Roger is still in the tournament, the probability that he wins the next round is a constant P. The random variable R represents the total number of rounds that Roger wins. Explain why the probability of Roger equal to is P squared bracket 1 minus P. Anybody know? Roger. So why is the probability of Roger equaling 2 equal to the probability equal to P squared 1 minus P? Yeah, so if he wins the first round, he is P. If he wins the second round, he is P. And if he loses the third round, 1 minus P. So it's like a probability tree, right? Win, win, lose. So P times 1 minus P is our P squared bracket 1 minus P. Okay? And you might have to write, because it says explain why, you can write capital letters for a sentence. He wins, then loses. Yeah? Because what's the probability of R equaling 2? That Roger wins 2 rounds. Well, he has to win, win, lose to win 2 rounds. Okay? Find in terms of P the probability distribution for R. Okay? So this is nice and easy. What do we have? R and the probability of R. So, he could lose. He could win and lose. Win, win, lose. 3, 4, 5. So then we got win, 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 lose. Win, 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 lose. Or win, 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 win. Okay? So, if he loses, we know that's 1 minus P, because the probability of him winning is P. If he loses, that's P lots of 1 minus P. We know that win, win, lose is P squared 1 minus P. So what do we think win, 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 lose is? Yeah, P cubed 1 minus P. Win, 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 lose? P4 1 minus P, and then P5 1 minus P. Is that right? No. We don't have the 1 minus P at the end. Don't get carried away. Because this is win, 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 win. There's no losing, is there? The tournament's over after 5. So, E. 3 marks just for that. Would you say that was good? Yeah, I do. Okay. Find the smallest value of P such that Roger's expected profit is at least as great as Serena's. Okay. What is his expected profit? We know that this is going to be 260, because that's how much you win, times P to the power of 5 minus 10. Because you have to pay the £10 entry fee, just like Sabrina. We want to know, when is this at least as great as Serena's? So we want it to be at least, yeah? Now, when it says at least as great, we can include Serena's. What was Serena's again? 7.69. Now, if you got question C wrong, in the mark scheme, if you have like, you get method marks for whatever you have. Okay. So what are we going to do? Add 10 to both sides. Okay, 17.69. Divide both sides by 260. And then fifth root it. Oh. Yeah. So I get 0.5841, etc. What do we like doing? Three significant figures. So P has to be greater than or equal 0.584. Okay. So there we have it. 3, 6, 9, 13, 14, 15, 16, 17 marks.